if I'm alive. Sunday, the internet went off. I didn't have any internet, so I couldn't work on the videos, so I decided to work on the videos yesterday on the methods thing, and that's why I didn't stream yesterday. And I think today I'm gonna stream only for 1 hour because I realized how can I say this? The stuff that I got into when I counted the methods. So I think there's around 54 different methods here, 54 different files. And I'm gonna have to make a clip for each one of them in order to make all of the videos. I'm gonna start with the array ones, and then do strings, and then the last one is gonna be objects. And strings is the one that has the most methods. So because of that, I think I'm gonna have to stream less during this time because I'm gonna have to film all these 54 clips and then edit every single one of them. And I think I'm gonna have to edit them separately because the plan that I have in my mind right now is to reuse the content. So once I make these videos and then once I finish the series after that, I'm gonna have 54 clips. And then I'm gonna put these 54 clips separately on the channel in order to try to rank with different titles and test different things. And I'm also probably going to post them on TikTok as well and just try to get traffic from TikTok by posting the link to my channel there. And as I was doing that stuff, I realized that some methods use regex, and I didn't talk about regex and the spread operator, so I think I'm gonna make a video about them before I do the videos on methods. And that's why I'm gonna study this today. I don't want to spend a lot of time on this though, because I think it's not that important to put on the series. So obviously regex is important, but it's not that difficult to understand how it works. And I think for someone that is starting out, it doesn't really matter that much. I almost never use regex, and then when I use regex, I just search for the pattern in Google, and it's gonna become even easier with ChatGPT. You can just ask for the pattern, and then you copy paste. You don't have to spend a lot of time thinking about the different groups and stuff like that. So I explain in a way that is the simplest as possible to understand. And so I can move on to the methods video. And also I'm going to talk about the spread operator. But it's better to review this stuff before I make the video.
A palavra regex deriva-se de
Today, as ever, we're going to listen to our subscribers, and a lot of them keep saying, well, you haven't really done regular expressions head-on either. So although I'm going to do my best to do regular expressions completely as a one-off, no previous experience needed, for those of you who look at it and think, oh, come on, this relates to something else, we will give you a link to go to the previous episodes and you can get more details about just how it links into other things. To those of you who think I must be infinitely old and personal friends of all these people, well, I am of some of them, but not all. And today's hero is called Stephen Claney. He's a man who, in the mid-1950s, invented regular expressions. What Claney wanted was a way that he didn't have to draw diagrams like this one, but that he could abbreviate what the automaton was doing. So I'm going to number these states 0, 1, and 2, and I'm going to label this one over here as being the finish state. And this is going to be an incredibly simple string fragment, a fragment of a string of characters that we're going to recognize. This is the automaton way of depicting it. At the start, you are in state 0, and we're going to say that in state 0, as you are analysing your input string, we put some input strings down here that this thing will be able to recognise. If what you see at the start of your string at the moment, not being coped with, is a letter A, then you go into state 1. If, let's take the simplest one I want to recognise, if in state 1, you code with the A. If the next character is C, then that is acceptable. So I write a C over that transition arc here, and that gets me into state 2. Usually the finish state is sometimes distinguished by drawing a sort of double circle like that. So you just glance at it, that's it. So yeah, What I've drawn there certainly recognises the string AC. Frankly, electronics engineers and so on were using these not in the late 50s, in the early 50s. They used them for creating and understanding what they called state machines. And as I say, Kleene sort of liked the idea, liked the pictorial notation, but wanted to see if he could get it to be more compact. So let's just finish the story by saying that if you come around on this loop and re-enter state 1, you can do so by recognising a B in the string. So we've already shown that it can recognise AC. You just come here, you start, you get an A, you see a C, and you're finished. But equally, as we now see, it will also accept A, B, C. Start here, see an A. If the next character in your string is a B, fine, you accept it, but you come back into state 1. Although it doesn't explicitly involve a stack, this is like a sort of iterative, recursive re-entry into the same state. But the only way out of that state to the finish is via accepting a C at the end of the string for number 2. You can keep going around this B loop as long as you want. It will certainly accept A, B, B, C, A, 3, B, C, and so on. And effectively what Kleene came up with as being a good way of talking about these things over the phone and not having to draw diagrams is to say in his regular expression notation that it accepts A, B star, C. And this is the first bit of Kleene invented notation, that star, which as we almost all of us now know means 0 or more of. Well, there we are then. The strings that automaton accepts is A, followed by 0 or more B's, finishing with a C. And the nice thing about this regular expression notation is just look at how compact it is. It is just so much easier to handle in a program than trying to do elementary computer graphics and literally draw yourself automata. Although for pictorially, I think everybody like this way of sketching out what your automata would accept. Those of you, some of you may have seen it, if not, follow the link out to the things we did about 3 years ago. You'll find there an automata that accepts 25 pence in order to issue a parking permit. It's all done with quite complicated but locally simple little transitions on either coins or characters or whatever. So just to underline and re-emphasize why this regular expression notation of Kleine's was seized upon because it was so compact, is let's complete the triangle. One side of the triangle is the automaton approach, and the other side of the triangle we've now seen is the regular expression approach, completely equivalent. But if we look at the Chomsky grammar approach done on the playlist, would that be compact and nice? Not so much. The rules on Chomsky grammars in their purest form is that if you use a capital letter, that is a so-called non-terminal symbol. There'll be another left-hand side rule that develops it further, whereas lowercase literally means what it says. So this means, well, Chomsky tended to call them all sentences. A sentence in this limited language is a little letter A followed by anything that a B can be. So I have to complete this. So I said, well, what could a capital B become? Well, again, look at the automaton diagram, which is completely equivalent. What happens with a B is you can spit out a lowercase letter B or a B, or you can have a much simpler rule that says a capital B can just become the letter C. So there we are. Instead of one small line, we've got 3 lines. And if you're doing it the grammar way, and you might say, well, can't you abbreviate that grammar a bit more? It's awful having to do 3 lines like that. It's very verbose. Yeah, here is the allowed shortening, but it's not much. Is you can say, all right, I will allow myself the luxury of the or bar and put a C there. So it's down to 2 lines now, not 3. What it's saying is a B can be a lowercase b followed by recursive re-entry into B again, or it can just be a letter C. So we'd have to do lines, but it's still nowhere near as compact and nice as the regular expression is. And what I must absolutely emphasize, can't emphasize too much, I should put double-headed arrows all over the place here, is that all of these things, the automaton diagram, the regular expression, the grammar, they are all completely equivalent to each other. Those of you who've been through mathematics courses will know your instructors go on and on and on about, no, I'm not asking it whether one is a subset of the other or one is contained within the other, but there's a little bit extra. No, they are completely and totally equivalent. There is not a single thing that one will accept that the other won't, and vice versa. So it's just a matter of convenience of the notation, perhaps if you're a computer scientist, for using in a programming context. And I think the other thing that also had to be coped with is to say, well, all right, you can do it as an automaton diagram, you can do it as a regular expression, as grammar. Regular expression is looking good because of the compactness of the notation. But are we sure that there aren't some snags in this process of saying they're equivalent? Well, one snag that did occur and was recognised very early on in the late 1950s, all of this, is that sometimes, looking at it, let's look at it from the automaton diagram point of view, sometimes you get a situation where what you want is what's called non-deterministic. In other words, I'm happy here because there's only one exit from 0 to get you to 1, it's labelled A. How would it be if I took another arrow out of 0 and said A could also lead you somewhere else? So let's just...
Hello everyone. In today's video, I'm going to be talking about regular expressions, and I'm going to be going in depth covering everything you need to know about regular expressions. This includes the simple stuff such as matchers, digit selectors, and so on, all the way up to more advanced features such as capture groups, negative look ahead, positive look ahead, and so on. So let's get started now. Welcome back to Web Dev Simplified. My name's Kyle, and my job is to simplify the web for you so you can start building your dream project sooner. So if that sounds interesting, make sure you subscribe to the channel for more videos just like this one. And now to get started, I'm on a website here which really helps with regular expressions. I'm going to link it down in the description below so you can go to the same website. But it's really useful because it highlights inside the text you're searching for what your regular expression actually matches, and it gives you details on every single thing that the regular expression is doing. It's great for practicing and testing out regular expressions, so I highly recommend you go down to the link in the description and follow along on this site. And now to get started, I first want to explain what regular expressions are. And essentially, a regular expression is a way to search through a string of text. So we have this text in here, and at the top we have a regular expression. And what that regular expression allows us to do is it allows us to search through that text in order to do things such as validation or get certain pieces of the text. We can do advanced find and replace. There's a ton of things that you can do with regular expression, but in general, all the regular expression is doing is allows you to search through text in a really advanced way and even group those different searches together so you can do powerful things such as find and replace with it. So to get started, I kind of want to break down the format of a regular expression. As you can see up here, we have a regular expression, and in the middle here we have
I'm gonna use ChatGPT to... I'm probably gonna... It's gonna be a very small video. I'm just gonna talk about what it is and some of the patterns. I'm gonna say that it is a pattern. It is something that allows you to search for patterns in strings, and it's probably most useful on search engines or things like that, where you have large databases of text. And this is the stuff that I was researching, I was using yesterday for creating the videos about methods. And they also changed the thing here on ChatGPT where you can see all the previous chats you did. And I renamed all of them so that I know which one is which. I'm gonna create a new one. Yeah, I think I will focus on one video at a time on the methods thing, starting by the array one, and as soon as I'm done with the video, I'm gonna upload it and go to the next. And then I'm gonna save the clips on a separate file for each thing. Separate folder. Regular expressions, regex are a sequence of characters that define a search pattern. These patterns are used to perform various operations on strings, such as searching for a specific pattern within a string, replacing substrings, and splitting a string into an array of substrings. The concept of regular expressions was first introduced by Stephen Kling in the 50s as a way to describe finite automata, abstract machines that recognize patterns in input. Abstract machines that recognize patterns in input. Regular expressions were later implemented in various programming languages and text editors as a way to search and manipulate strings. One of the earliest known, this use case, I think, maybe it is not complicated to talk about because I already talked about compilers in the second video, I think. So maybe I'll talk about that. One of the earliest known implementations of regular expressions was in the KeyED text editor developed by Ken Thompson in the 60s for the Unix operating system. Thompson's implementation of regular expressions, called pattern matching, was later incorporated into the Unix utility graph, which stands for Global Regular Expression Print. Oh, so graph uses regular expression. I think you can use regular expressions or you can use normal text, I think, graph. Today, regular expressions are used in many programming languages and tools, including Python. What are the most used? Lists 7 of the most useful use cases for regular expressions. Searching for patterns within a string, validating inputs. Oh yeah, the email validation is a good one to talk about as well. I think I'm gonna get pictures of this. What I'm gonna do is search for these use cases with images, and then I'm gonna get a picture for each one of them, and then I'm gonna briefly talk about them and put the pictures there on the video and say what it is or why it's useful, then briefly talk about the most common patterns to search for that are used to search. For example, caps lock letters or letters and numbers 0 to 9. But I think I don't wanna dive deep into this stuff. And then what's the best way to explain spread operator? So I'm gonna remove some of this. It's quite redundant. Splitting arrays. What are the 10 most useful patterns used for searching with Regex? Yeah, I think I'll briefly explain what it is, say where it's used most often, these 4 places here. And then I will briefly explain what are the 10 or some of the most useful patterns that are searched for. Or just show this response here. Take a picture of this response and then show it in the video to not waste a lot of time. And I think that's what I'm gonna do. So, talk about what Regex is. Talk about most useful use cases. Show used patterns. Talk about spread operator. Yeah, I think that's gonna be it for the video. Save this file as the outline for the video. It didn't put the numbers and letters besides the... I'm talking about the actual numbers, not the special symbol for finding the digits. And also the A and Z stuff, which is for letters. After this question, I'm gonna start asking questions about the spread operator. Yeah, the only problem with this is that I don't know if I can trust the output. It looks like it's right based on the patterns here, but obviously I'm not sure. So it doesn't work on anyone. So it's probably incorrect. So I'm gonna have to search on DuckDuckGo for this. I think these responses are probably correct. Yeah, I think it's correct. And just showing the picture is probably enough. Yeah, when I talk about the use cases, I'm gonna show a picture for each one of them. I'm gonna get a picture of the email, of a email failing or something like that, and then put the regex on the side. Just have to make sure that is the correct regex for email validation. So for cleaning and preprocessing data, I'm not sure what to show. Yeah, maybe I won't talk about this because it's too complicated. It's something like if you do a web scraping and then you're getting a bunch of text and want to filter out the text, then you probably use this, or the thing that I was doing with the poker analysis tool of parsing the text in the way that you want. I used regex for that. Maybe I can use actually. Yeah, I think I'm gonna use that actually. Because I remember that I had the text on one side and the IDE on the other side. So that's very clear to see what's going on. I think that's a good idea. And then maybe I can link the videos on the description. So what I'm going to talk about is spread operator. Right back. Spread operator is a syntax in JavaScript that allows an iterable, such as an array or string, to be expanded into individual elements. It is often used to spread the elements of an array into separate arguments when calling a function, or to spread the characters of a string into an... Oh, I think I can go back to the other video that I did explaining the arguments, asterisk arguments on Python, and say it's the same thing. So the spread, the equivalent for spread operator in Python is the asterisk. So I think the best way to explain it is that it's a symbol that allows you to, when you put it before the name of the array, it allows you to write all the elements of the array without having to write them manually. I think that's the best way to say it, to explain. And the same thing happens in Python. Oh, it allows the whole thing to be write down as individual elements. Yeah, so I'm gonna make some file here. Maybe just spread and I'll understand. I'll copy this stuff. Yeah, then I think I can make, I can highlight this stuff here, and then make several different arrows representing that this stuff is each individual element. And that way you can write the whole thing without having to write element by element. I'll search for images for Regex email validation. I'm gonna use this one. I probably won't find the image with the email validation and the regex side by side, so I think I'm gonna get this image here and then get the regex image separately. and then put them side by side, or just take a picture of the Regex test website. I think I'm gonna take the pictures from the test website because it's easier, and that way I can also talk about the website that tests that. I'll link the website on the description as well, in case people wanna see it. Oh, the pattern that I had there was one that I used before, probably. So I'm gonna have just search the pattern separately. I thought it was a pattern that came with the link that I clicked, but I think I used that website a long time ago, and then coincidentally it was testing for emails. I don't remember really well. What the fuck? I think this is fine. Yeah, this is the thing that I was looking for. I think I'm gonna take the picture with the link. And then I'm gonna save this link here. So let me see. Yeah, the picture of the patterns. At this one I'm just gonna show the picture. The most useful cases is gonna be this stuff here, where I'm gonna show the pictures. So this one I have to do. I should put this on a different text editor so I can highlight the ones that I have already. It's not a big deal. It's gonna be really easy to do this video, I think. Just gonna gather the pictures and then film it. I think I'm gonna do this right after the stream. And then I'll start filming the videos for the methods, which I think is gonna take a long time. So I have to get the picture for the poker, the article, and then the search engines. Python, the equivalent to the spread operator in JavaScript is the asterisk operator. The asterisk operator is used to unpack an interval such as list or tuple into separate elements. Here's an example of using the asterisk operator to unpack a list of arguments when calling a function. This example, blah blah blah. If I thought about that before, then I could incorporate the spread operator in the function video. Don't know, I didn't think about that because I was thinking about it in a different context. I didn't think about making that connection. So I think what I'm gonna do with the spread operator is just talk about the other video. I'm gonna say, remember when I said on the videos about functions that you can use this asterisk to call multiple arguments. The problem is that I think I deleted the picture that I used for the video. Oh no, I still have here. Nice. Yeah, this one. I'm gonna use this picture here. Then I'll talk about the previous video. Yeah, that's what I'm gonna do. Yeah, so I think I'm gonna stop here before 1 hour because there isn't anything else I can think of. I think that's it, and then I can take the pictures really easily. I'm not sure if that's the right way to say it, but I'm just trying to think about see if I can do anything else before until I reach 1 hour. Or maybe I can do the Italian stuff. I'm gonna do the Italian thing with the text-to-speech, and then I'm gonna stop. Because I don't think it's worth spending time studying anything else when I have all these other videos on my mind, so.
Fa,
Fa,
does,
fisso,
fisso,
set, unchanging,
3,
3,
3,
desiderare,
desiderare,
desire,
aria,
aria,
air,
bene,
bene,
well,
anche,
anche,
also,
giocare,
giocare,
play,
piccolo,
piccolo,
small,
fine,
fine,
end,
mettere,
mettere,
put,
casa,
casa,
home,
leggere,
leggere,
read,
mano,
mano,
hand,
portare,
portare,
carry,
grande,
grande,
large,
compitare,
compitare,
spell, words,
aggiungere,
aggiungere,
add,
anche,
anche,
even, also,
terra,
terra,
land,
qui,
qui,
here,
devo,
devo,
I must,
grande,
grande,
big,
alto,
alto,
high, tall,
tale,
tale,
such,
seguire,
seguire,
follow,
atto,
atto,
enact,
perché,
perché,
why,
chiedere,
chiedere,
ask,
maschi,
maschi,
men,
cambiamento,
cambiamento,
a change,
è andato,
è andato,
he, she went,
luce,
luce,
light,
tipo,
tipo,
kind of thing,
spento,
spento,
turned off,
bisogno,
bisogno,
need,
casa,
casa,
house,
immagine,
immagine,
image,
provare,
provare,
try,
noi,
noi,
us,
di nuovo,
di nuovo,
again,
animale,
animale,
animal,
punto,
punto,
point,
madre,
madre,
mother,
mondo,
mondo,
world,
vicino,
vicino,
near,
costruire,
costruire,
build,
se stesso,
se stesso,
himself,
terra,
terra,
earth,
padre,
padre.
father,
Yeah, I think I'm gonna stop here. I'm not sure how frequently I'm gonna stream because I wanna finish this stuff first. So I'm gonna try to make the videos as fast as possible. I think I was I'm gonna try to. I'm gonna start with making the videos for methods first because I'm thinking about that for a longer time. And then once I'm finished with the videos for the array methods, then I'll go back and film the regex stuff, this video here. Hopefully I can do this by today, and then I'll continue to do the other stuff. So until I do this, I'm not sure if I'm gonna stream tomorrow or the day after. So, but I'm pretty sure I'm gonna be